Hey folks, so today we'll talk about the vector search, the RAG systems, and what's more interesting, the vector search together with the metadata. And for me, the RAG systems are more workarounds for our modern interaction with the LLMs because we actually have the limitation of the context window. Yeah, so the context window allows us to do a lot, but the problem is that we could not fit everything there. And even if you will able to fit everything there, maybe the overwhelming of the LLM with the information will create yet another problem. So we have RAG right now as the best what we could offer, even if it's a workaround. And how it usually works that you do the vector searches and similarity searches and just put to the context something that correlate with your message or anything else. It's simple. And right now, as an answer to this, a lot of vector-oriented databases appear that allow us to search information and the chunk of text and some multimodal data quite fast. Yeah, and all these databases actually have at the beginning was focused mainly on text documents and have no ability to add the metadata. So it's super simple that you have your PDF, you slice it to the chunks, do the vector embeddings, and then use this vector embeddings for the search to put to the context relevant data. And it was working quite well. It solved a bunch of problems. Even now, for majority of our RAG pipelines, it's good enough. But if you're talking about more complex RAG systems like graph-oriented RAG, that maybe combine the vector and the semantic data together with the vector search, we get some challenges that not so well addressed with such databases, because right now you have a need to combine the vector embeddings together with some kind of structured data, and some databases just offer you to add the metadata to the vector embedding. Like you have the metadata and you have the vector embedding, just a chunk of text, and then it's works somehow. And it gets more interesting how combine the result of the vector index search together with the metadata, because the majority of the databases have this metadata not as first citizen in a structure, and it means that still your main focus actually it's an effective search on the vector index, and somehow it happens in an isolation from the metadata. And we could discuss a lot of data models that actually bring this to the reality. And Quadrant, for example, they already have some capabilities to make the metadata search more effective, but still it's somehow still isolated process that jump on the beginning of the vector search or the end of the vector search and so on. So for example, at Kin, we use the LibSQL, and I wrote a lot of articles how to make the vector search possible for the knowledge graphs, and how to combine the graphs with the vector search and all the things. So we have wide variety of the metadata together with the vector search that in a core of our data model. And so I will talk more about this. But quite fast recap that the LibSQL folks, they made an amazing job that grabbed the regular SQLite, and without building the extra types, they just extend the blob type to persist the vectors and create the infrastructure around some special functions that you're able to calculate the distances, you're able to create full scale vector search indexes that extremely effective on the large amount of data that persisted on disk. They use this flush INN algorithm that really leave the super small memory footprint and capable to work with the huge amount of data stored in a database. So if you want to know more about the LibSQL and vector search, read my Medium articles. I will leave a couple of links in description of this video. Maybe I will make another video about this, but I described practically everything in my articles in a series of 3 of them. But getting back to our example, imagine that we have, for example, the conversations in a chat for the AI agent, and we have the summary of the conversation as a text. We have the embeddings that allow us to search this conversation, and together with this conversation, actually, we have a couple of metadata, like the start and end date when the conversation happens. And if we want to filter the conversation by date, it's super simple. If we want to search some conversation by relevant question, we could do the vector search. But what we should do if we, for example, want to get the conversations for the last week, that we, for example, have some concrete question. And in this example, we have the combination of the metadata together with the vector search. So how to make it happen? First of all, how the LibSQL works, they give us the special table function that we could specify the vector index and specify the amount of items that we could take out of this index. Yeah, so you could see it as an isolated table actually. So, and it means that you still could write the query that could combine the result of the vector index together with the metadata search. But you have the challenge that on practice first, you will get the result of the vector search that already will be limited by some top amount, and then you will combine it with the metadata, and it's mean that you could filter out some results, or you need to even be more aware that the result of the index do not guarantee you to return all the data. So you should be careful that you get the sum of the data, and some of the data could be missed. And LibSQL do a really good job. It's really simplified the things and make the mental model much easier, but you need to be aware that when you use this special function, you actually get already pre-filtered data set. And what we could do about that? So it's 2 big strategies that we could apply to combining the metadata with the vector search. So first of all, if we're talking about the LibSQL, we could do the trick that we could make the window bigger. Yeah, for example, we always target for 10 top or 20 items, but we could go further and just largely extend the window of the search and hope for good that our results will be there, and that result of the vector search will be most limiting factor of the filtering of the data. Yeah, that we focus more on getting relevant vectors and then just filter them on the metadata. And this approach actually called the post-filtering, that first we do the vector search, and after that we just filter the vector search based on the metadata. And it will work quite well when the filters on the vectors is the main filtering factor. Yeah, that we will filter out the majority of the relevant things by the vector. And it's the post-filtering. Pre-filtering is not so easy to do, because pre-filtering means that your metadata is most limiting factor. Yeah, that the metadata will filter out the majority of the of your vectors, right? And it's critical to do this before we go to the vector search. And here we have a couple of different strategies. First of all, we could denormalize the data and keep maybe separate table for this pre-filtered data things. So you keep the table that have more specific pre-filtered data, then you could apply the index vector search on top of it. It could be quite expensive, and it could force you to store big amount of the duplicates in your database, and not always is possible, because if you're talking about the dates, it's mean that it's quite hard to build this denormalization data. Maybe it's easier to build this denormalized data when we have some search queries. Have I talked about this the previous week or something like that? Then we could build it because it's more stable. Then you have the factor like the previous week and all the rest, right? But if you have the dynamic range of the dates, it's not feasible. So what we could do? In a case of pre-filtering for the same use case, what we could do, we could really pre-filter with the date range, and maybe date range will be most filtering factor. It's still questionable. You need to run the experiments on your data sets. So you have the data set that already have pre-filtered. And then instead of using the index, you could just calculate the differences and search based on the differences. And, it's one approach. So we don't use the index at all, but we still rely on the Gaussian similarity. Another thing that we combine this pre-filtered IDs to filter the result of the vector search. And here it will be not so much difference, but it's always possible. So we have a couple of options. We could do the post-filtering, we could do the pre-filtering, we could do pre-filtering, and then if a data set is small enough, we could filter on the distances of Gaussian similarity. So I still hope that in some point we will get the possibility maybe to pass the metadata to the functions that do the vector search, and that will do it more effective. Or maybe we will have the ability to have the direct access to the index and maybe some cherry pick something from it. So, but already we have some strategies that allow us to work, and the LibSQL give us the amazing possibility to incorporate the metadata together with the vector search, because the philosophy that the LibSQL, for example, have, that your vectors live together with the data in the same space, and it's not even the metadata, it's just the data with some vector capabilities. And I really like it much more than another approaches that, for example, the classical databases with vectors have, and some of them doesn't even have the concept of the metadata. So read my articles about the LibSQL, study something about the LibSQL and vector search. Is amazing. I really encourage you to do so. And let's stay connected. If you want to know more, or you have some really cool complex cases, let me know. I will be keen to hear from you. So have a nice day. Choose.